This is 6.1, day 1, and the only objective that we are going to cover today is finding the sum, difference, product, and quotient of functions. Now, the notation might look a little bit different for these, but it's all things that we've done before. For addition and subtraction, remember the f and the g are just the names of the functions that are being used. F plus g of x really just means that we're going to take f of x and we are going to add it to g of x. Same thing happens when it says f minus g. Be careful when it's subtraction that you continue to subtract the entire way through the problem. For multiplication, if it's multiplication, it will indicate that it's a closed dot. If it is an open dot between the f and the g, that means composition that we'll learn on day 2. So be paying close attention to if it's a closed dot or an open dot in between the f and the g. And then with division, we don't actually have to work out all of the polynomial division like we did in chapter 5, but we are going to want to indicate what x can't be if there's a restriction on the domain. So pause the video if you still need to copy this. Okay, for each one of these, it's asking us to find f plus g, f minus g, f times g, and f divided by g. So remember when it says f plus g, we are simply going to add the f of x equation, which is x plus 5, to the x minus 4, which is the g of x equation. And we're combining like terms. So I have 2x plus 1. For the subtraction one, we are taking the f of x equation and we are subtracting the x minus 4. Now, remember, we are subtracting the x, and that means that we are subtracting the 4, so that changes to a plus 4. X minus x gives me no x's. 5 plus 4 gives me 9. For multiplication, we choose usually to use multiplication with a box. So I'm going to draw my 2 by 2 box because it is 2 terms times 2 terms. So I have x times x, which is x squared, x times 5, 5x, x times negative 4, negative 4x, and 5 times negative 4, negative 20. Now we're just looking to combine like terms. I only have one x squared. Negative 4x plus 5x gives me positive x. And then negative 20 is all by itself. For division, f is first. Now with all of these, the order matters. Because it lists f first, that's the first equation when we rewrite it. If it listed g first, then we would write the g of x equation first. So f is first, so it goes on top. Divided by g of x, which, whoops, we'll try that one again. Okay, so in this problem, I'm not making you actually solve anything out. You're just showing me that you know it's division. But we need to also indicate that the domain is not just all real numbers like it is for the previous 3 problems. In this case, we need to figure out what would make x equal, let's try that again. We would need to figure out what would make the denominator equal to 0. And the answer to that is if x was 4. If x was 4 here, that would make the entire denominator equal to 0, which would be undefined. So in addition to this as my answer, we also need to indicate that the domain has a restriction. X cannot equal positive 4. You have to state both things. For the next problem, f of x is x squared and g of x is 4 minus x. So when we do f f plus g, we have x squared plus 4 minus x. And we're combining like terms. There isn't a like term for x squared, so it gets by itself. There isn't a like term for the 4 or the x, so they just get written next to each other. It's probably in your best interest to rewrite this in descending order. For subtraction, I have x squared, and I'm subtracting 4 minus x. Remember, I'm subtracting, so that means that both of these signs are going to change. So x squared doesn't have a common term for it to subtract from, so it stays as x squared. And then I have negative 4, and then positive x. Again, probably in your best interest to rewrite these in descending order. For multiplication, we have x squared times 4 minus x. Now you could just distribute this as well. I'm just showing how the box would be used. So I have 4x squared and negative x cubed. The x cubed is the highest exponent, so I'm going to write that one first. And then division. F of x, so that's x squared, goes on top. And on the bottom, I have 4 minus x. And again, because I've got an x on the bottom, that means that there's got to be a number that would make that denominator equal to 0. And I need to find out what that is because it restricts my domain. In this case, once again, x can't equal 4 because 4 minus 4 would give me 0 in the denominator. So in addition to this as my answer, I need to also indicate that x cannot equal 4. For C, we are adding 3x squared and 5 over x. I don't have any like terms, so I'm just going to leave them exactly as they are. Same thing for subtraction. I don't have any like terms, so I'm going to leave them exactly as they are. Now, technically, there are domain restrictions for both of these, because in this case, if x was equal to 0, it would make the entire denominator here 0, which makes it undefined. So we also need to indicate restrictions here. The only time that there's a restriction on x for these problems is if there is an x found in the denominator. For multiplication, I have 5 over x times 3x squared. Once again, it could be set up with a box, but it would just be a 1 by 1 box. And I would have 5 times 3, which is 15, and x squared on top, and an x on the bottom. The x on top and the x on the bottom are canceling out to give me just 15x. For division, I have 3x squared on top, and on the bottom, I have 5 over x. Now, we don't like to leave this as a complex fraction. That's where you have a fraction within a fraction. So we're going to rewrite this problem. Remember, when you are dividing fractions, you are really multiplying by the reciprocal. So what I really have for an answer here is 3x cubed over 5. And there's no restriction on the domain then. Okay, the last one. I'm adding, so I've got x squared plus 7x plus 12. And I'm adding to that x minus 3. I'm just lining up my like terms. So I have x squared, 7x plus 1x gives me 8x, and 12 plus negative 3 gives me 9. Subtraction looks very similar. and I'm subtracting x minus 3. I'm subtracting, so that makes them both change their sign. So I have x squared, 6x, and 15. Multiplication is a little longer this time. X squared, 7x, and 12, multiplied by x minus 3. So with this, I have x cubed, 7x squared, 12x, and then the bottom row, negative 3x squared, negative 21x, and negative 36. Combining like terms gives me x cubed, 7x squared, plus, x cubed, and then 4x squared, because the 7x squared and the negative 3x squared combined together. The negative 21 and the 12 also combined together. So I get negative 9x minus 36. And then finally division. X squared, 7x, and 12 over x minus 3. Now, always check with this. It won't be the case with this problem, but later on in the chapter it will be. Always check to see if you can factor something that looks like a trinomial. And in this case, we can factor it. X plus 3, x plus 4. The reason why we check is because if these were exactly the same factors on top and bottom, they would cancel, and it's still a restriction on the domain, but something different happens later in the chapter, and we'll talk about that when we move on. Make sure you grab your worksheet and get started on your homework.